So we'll talk about how, what are the suite of things in the toolbox? How do you go about thinking about them? What do you use them for? And why did they get to be where they are? So as I said, you've got a large array. Well, this doesn't look like that big of a set, right? There's only 3 things, right? Dual stack, tunneling, and translation. You go look at all the RFCs and try to figure out what am I going to do, and there's all these technologies, and that isn't 3 things. That's a lot of things. It turns out that they all fit in these 3 categories. So dual stack is the thing you keep hearing from everybody. Part of the reason we talked about this morning in terms of your ability to fall back when things don't work. But when I was actually pushing this in the working group, because they were all wanting to do translation, because that sounds like the easy thing. I've got v4, I want to go to v6, or I've got v6 and I want to get back to v4, just translate it. Sounds easy. But if you've ever actually run a network that way, you understand how bad that path can be. And if you take the path of just put the new one out there, leave the old one alone, you can now go along and say, on a business case by business case basis, I'm moving mail this week, and just move the mail over. I'm moving the web servers this week, and just move the mail servers over, right? The infrastructure is capable of both. You don't have to have every application move in one shot. If you're doing translation, you have to have the translator be capable of all the apps simultaneously. Right? That's hard. If you try to go in and wait till the last possible moment to do your deployment and transition, guess what? You're going to have to move all the apps at once. That's expensive. It's difficult. Not to expose too much of Cisco's dirty laundry, but our IT department tried that. They put together a plan that said, guess what? We've got to get v6 done. We waited a long time past when we should have got started. We're going to get it all done real quick now. So they put together this massive plan, and they went into senior management and said, here's how much it's going to cost. And they got thrown out of the room. Right? If you wait too long, the budget numbers that you're talking about for doing a coordinated move are so high they draw attention. You want to slip this in under the door with nobody paying attention. Put v6 out there, make sure everything works, go on an application by application basis, and nobody knows it happened. Now that's the grand plan. Reality says you can't quite get there, right? There's going to be devices that are not capable of v6 right away. And you don't really want to pull those in and say, I'm going to replace that device right away, because that causes it to become a cost issue again. So that's where tunneling comes along. And there's a variety of forms of tunneling we'll talk about. And finally, you get to the point of, at the end of the day, you've got this v4 only printer that you just bought, and it's going to have to last for 20 years. And you've got this shiny new little PDA thing that does v6 only, because that's what the wireless providers are giving you. And you still have to make those talk to each other. So you still need translators. You just don't want to build the whole plan around the translator. So taking each of those and trying to break them down a little bit, what are the pros and cons of each approach? Right, so dual stack allows you to move one application at a time, as I said. And it allows you to do it on a local business case basis. We heard a lot of discussion this morning about how do you build the business case, or maybe that was just after lunch, I lost track. Right? How do you build the business case? Well, part of building that business case is to keep the number as small as possible. Do it over time. Tunneling allows you to traverse infrastructure. Right? Doing translation in the network enables communications between disparate devices. But there's downsides to each of those as well. Doing something over time means you have to have v4 for a longer period of time. The carriers are bumping into the problem where they won't be able to go to IANA to get more address space for new customers. They can't really afford to operate parallel infrastructures for a long time. Doing tunneling for a long time actually increases your complexity. We talk about Hurricane Electric and 6XS tunnels from the home. Well, that's fine as long as it's you managing your tunnel to them, but they don't want to deal with the complexity of managing a bunch of tunnels on the other side, right? So those are set up in an automated way. But there's a lot of other ways you can do tunneling, and some of them are more automated than others. Finally, the downside of NAT is NAT, right? It should be fairly obvious. But, between V6 and V4, it gets worse because you now have namespace collisions that become very obvious. Whereas in V4, you've got two separate namespaces to go with the two separate address spaces, but the names kind of match, and you get 32-bit answers in both, and so you can fudge it. When you're getting 128-bit answers on one side and 32-bit answers on the other side, and the NAT has to know what answer was given on what side, it gets to be a lot harder. This is why the IETF deprecated NATPT, the initial stab at a translator. When Elaine and I were working group chairs, this proposal came up. Our immediate reaction was, make it experimental. This looks too dangerous. We were overruled. Lots and lots of people said, we absolutely have to have this, and it has to be a standard. Fast forward 5 years, everybody goes, oh, that was a really bad idea. Make it historic. Make it go away, because that one just didn't work, right? So, there's a lot of things that can be done that maybe aren't so obvious in the long run how bad it's going to get. One of the issues with NAT, especially when the carriers operate it, is how do you train your first level ops to deal with the question of what was the source address and what was the destination address and what was the path? Right? If you're in the bottom part of the drawing, dual stack, it's fairly straightforward. It either went V6 or it didn't. Right? If you're in the top part of the path, how many NATs are there in the path? Who's operating them? How do you know which path it was in use at a given point in time? Because by the time you get the trouble call, routing's changed. Right? If it starts V6, does it stay V6? Or did some DNS translator thingy along the way say, oh, no, I know that's a V4 thing, and give you a 32-bit answer, which you then translate again on the other side back to V6. So you now have gone from 6 to 4 to 6, and things don't quite work right, even though you thought it was 6 to 6 all the way through. A lot of questions come up. How many organizations are there between the application endpoints? If you're an enterprise, how many organizations are between the application endpoints? Anybody believe it's just one? If you're an enterprise and you believe there's only one organization, you probably don't really understand your enterprise. Because the network guys and the in-system management guys generally don't talk to each other. Right? They throw rocks at each other, and it's two separate organizations right there. Yes, there's one CIO, but it's at least two separate organizations that are in charge of the end-to-end application experience. What are the investment cycles on those multiple organizations, right? If you've got carriers along the path, do they all have the same investment cycles? Some of them are going to be ready to put V6 equipment out sooner than others. Some of them are ready, but they can't get the budget together in time, right? You get back to the question of, okay, what's the motivation for each organization to move? And more fundamentally, what's the motivation for one organization to help another one? To the question we had this morning about applications, right? Everybody perceives this problem is the broadband provider's problem because they're the ones that are not getting address space to add new customers. What's the motivation for the content provider to do something to make the broadband provider's life easier? There isn't any. The flip side of that is, unless the broadband and all of the infrastructure providers along the path are doing what they need to do, what's the motivation for the application developer to do anything? If they enable V6 in the app and it starts timing out and doing other bad things because it gets confused, that's going to make their app look worse. They've spent more time and effort building a V6 capable app, which makes them less competitive to begin with. Even though in the long run it's the right thing, in the short term, it's a hard problem. And in fact, everybody's looking short term. So you end up with this cycle. So you have to break that somehow, right? So one of the pieces I left out of the introduction was, I spent 5 years at Microsoft, and I was actually the program manager for IPv6 in Windows XP. Right, so I set the direction, put the stake in the ground and said, go that way, and then I jumped over to Cisco and said, guys, they're going that way, we better get ready because they're going that way. Right, but fundamentally the point is to get the application developers to move, the API just has to work. If the application developer starts to do something and the API doesn't work because there's some infrastructure piece missing somewhere, they're not going to bother. They're going to sit back and wait. Right? So the API just has to work. This is why Windows XP tunnels as much as it can. Right? It'll tunnel over v4, first choice. If it can't get that to work, it'll tunnel over UDP. Right? The reason is it just wants to make the API work. And when I left, on my board was tunnel over HTTP. Make the damn API work so the application developer will do their part to break the chicken and egg problem. So.
The problem with all that tunneling, though, is I've ran into more than one suggestion from regular users or gamers of anyone where the tunneling breaks their older routers and whatnot, and it ends up becoming a hindrance for things rather than improvement.
Okay, so the point is that a lot of people have anecdotal information that says the tunnels break things in a variety of ways. Well, sure. No, I understand the point, right? But in almost all of those cases, you will find that there's some device in that path that is intentionally operated to break things. It's a firewall. It's intentionally operated to break things. Occasionally, you will find things like DNS giving the wrong answer because it got confused. Right? But by and large, when you find breakage in these tunnels, I go all over the world, and tunnels just come up and work. Right? I happen to get to a hotel where it doesn't work. Call the help desk. Their response, turn v6 off. You shouldn't have that. They're intentionally blocking it. Right? But I go to all neighboring hotels and it works just fine. Right? So yes, there are issues. Yes, it's not clean. If you want to manage service, and we'll come back to these points, it's not the best path. But this is why I chose this path and pushed it, right? You have to break the chicken and egg problem. Somebody has to go first. You can't get the application developers to go first unless it just works. If you say, well, the broadband providers and the infrastructure providers should go first so that you don't have to do this tunneling, that's all well and good. But they're short-term focused too. So they're going to roll out $100 billion worth of new infrastructure, and there's no apps for 5 years. They'll all be fired. Yeah, and guess what happened over the last 10 years? The apps people didn't do anything. Well, with one exception. We'll come back to that. So drawing from the toolbox. You don't want all the applications to move in sync. Anybody who's tried to do major moves of infrastructure knows you want to try to partition things off as much as possible. So you want to make it as simple as possible for the old stuff to keep running while you're working on one piece. Leave everything else alone, focus on the new thing. Lots of the infrastructure is not going to be v6 capable right away. In particular, last mile in wired infrastructure. That equipment is, has depreciation cycles that are generations long, right? So they won't replace that stuff for a while. Tunneling over that is an appropriate way to handle the problem. And you do need to eventually get to translation. All of these get to be used together. You don't pick one. Any given network will actually have combinations of these in various places and at different places over time. So to get back a little bit to what Dave Ward said this morning, he was looking at a particular set of data that's monitored by Google here locally, or actually Comcast. This is looking at what was going on in France. And the exact numbers don't really matter. This is year-old data by and large. But what's most notable here, and the thing you need to pay attention to, is the event on January 27th this year. Anybody besides Martin and Elaine know what that event was? That's the day Google turned on YouTube to v6. They started advertising that Quad A. And multiple places saw traffic triple on their v6 networks. Bang. And it keeps going up after that. The point of putting this out here is you shouldn't be thinking in terms of growing the v6 network and getting things in place and moving things along and getting the applications together. The point of this is when that application is there and the Quad A is there and the infrastructure is ready, whether it's tunneled or not, and this happens to be tunneled, right? It's going to switch. That came off the v4 network, and it won't go back. When I was at Microsoft, I had been in the IT department, and I moved to the Windows group, right? So I'm doing this XP thing with v6. And if you go back and you look at some of the betas for v6 and XP, it was on by default, no knob, no way to turn it off. And the IT guys are all screaming at me, you have to give us a way to turn this off. I'm going, no, I came from IT. I know what would happen if I put a knob in there. First thing you would do is turn it off. No, there's no knob. It's just on, right? The API just has to work. And they just could not believe it. And I said, look, you have a knob. It's called DNS. If there's no Quad A, it stays on v4. As soon as there's a Quad A, you're going to get this, right? So in fact, Microsoft is one of the places that's worse off in terms of how quickly things are going to move. Because the way their DNS infrastructure works, it's very dynamic, and the hosts, as soon as they're capable, start advertising themselves within the internal domain, and poof, their traffic goes from 4 to 6 overnight. They put knobs in after I left. I understand. Well, and certainly you don't want to have unknown exposure points on your device. And if you don't know anything about v6 and it's got exposure points, that is a security issue. But that's not, this is taking the other stance and saying, look, guys, the API just has to work and push that out, right? So even if I'd been there, we would have put a knob in. It was more of a make the case that there are knobs. They're different knobs than what you're used to. You have to go look for them, think differently. So there's lots of technologies to choose from. I'm just putting a few of them up here, right? And we've talked about dual stack. These are a bunch of the names that you'll find when you go looking around. All of them but the bottom two on the right are actually tunneling technologies, right? They do tunneling in different ways. They're intended to tunnel between different places in the network. ISOTAP in particular is designed to be run within an organization, right? It doesn't mean it can't run anywhere else. It just means it's designed to be able to run within an organization. For a long time, I was telling people, you actually want to run 6-4 and ISOTAP back to back on the same router. Internally, it's doing ISOTAP tunnels, so you don't have to have any v6 infrastructure except the end host, the one router, and it's doing tunneling over v4 in both directions, and it's just doing different encapsulations. It's the same fundamental technology. One router, you're up. You didn't have to do anything else. You don't have to wait for your ISP to get around to it. Nowadays, you've got more choices, and you'll hear more about those later. The real issue is you have to go think about what is it your network needs? Where are the places you're trying to get to? Where do you need v6 to be and on what time frames? In large enterprises in particular, you may be able to get away with having some native deployments dual stack in some focused areas, but then you've got outlying offices that the budget isn't going to get around to those for another 3 years. Don't make them wait 3 years to get v6, tunnel. That's what it's for, right? Use dual stack whenever you can. Use tunneling whenever you need to. Use translation when you have to. Right? One of the issues you'll hear more about, I'm pretty sure later on, is how do you actually know you've got v6 connectivity? You know, the CPE devices in particular have this concern. What are your cost constraints? There's a lot of issues in terms of cost that get wrapped up into this, and you have to go back and think about it. There are tools out there that can help you understand where your infrastructure is today relative to being able to turn v6 on, and then how much it's going to cost to get it from where it is to where it needs to be. You hear a lot of people complaining about 6-to-4 and Teredo, especially lately. Google's actually been on a campaign to try to get them killed off. And their reasoning is that they want a managed service. And those are unmanaged capabilities, right? They're intentionally put out there as a bootstrap that says, best effort, if it works, it works. If it doesn't, there's nobody to call because you don't know where the packet went anyway, right? And they're out there, and if you're really expecting managed service level kinds of responses, you're not going to get them with those technologies. So they're all upset that these things exist and are out there. At the same time, having them out there actually gives them some leg up with the service providers to get moving, right? Because Google's trying to move, and they can't get a reasonable level of service as long as this stuff exists. And the only way to make it go away is for the service providers to offer native service, right? So it's a double-edged sword where, yeah, it's bad, but you know, sometimes using a bad thing to beat somebody else is actually going to result in a long-term good. Tunnel brokers exist and are deployed in a variety of forms. 6RD and DS Lite are the new emerging technologies which are, you know, trying to bridge the gap between where 6-to-4 started as an unmanaged capability and move it into a managed context so that the service provider is doing a tunneling across internal infrastructure. Yes, it's still the same encapsulation, decapsulation process, but the two endpoints of the tunnel are inside the service provider space. So they have complete control over that, and from the outside world, you don't know it exists. As I said, ISOTAP exists for inside the enterprise, and so you may end up with multiples of these along any given path. Oh, yeah, dual stack doesn't exist. Well, it does in some parts of the world, but not really in this part of the world, right? You know, yes, concession to Martin, yes, it does exist in San Jose. But, you know, how many people are actually his customers sitting here in San Jose getting a dual stack feed from him today? Probably not very many. At the end of the day, which technology you choose doesn't matter. It's a locally significant cost-based decision. You can use multiples of these. I have dual stack in my house, have had for a long time. I also run ISOTAP. Why? Because I want to make sure that that technology is still working the way it's supposed to be working, right? It's making sure that all the pieces come together. I do have some v4 only stuff around. Eventually I'll have some v6 only stuff, and I'll have to have a translator. Unmanaged technologies should not be in the path of a managed service. Just don't even go there. So you have to think about the way the technology gets deployed and what your intent is at the end of the day. If we look around the world, you know, this particular graph was put together by Google probably about a year ago. And looking at the amount of v6 that they could already see, where in the world is it coming from? And they were surprised to find that, you know, there's a very large amount coming from Russia already, right? Happened to be mostly Opera, from what they were seeing, right? In the US, it turned out that most of what they were seeing was actually 6-to-4 connections off of airport extremes, right? And you can tell by, there's bit pattern signatures in these devices. So I can tell you whether you've got a Linksys device that's doing 6 to 4 or an Airport Extreme that's doing 6 to 4, even though in theory you shouldn't be able to know. If you look in the right place, you can tell, right? And in fact, you can probably tell D-Link as well. I haven't actually looked at a D-Link box, but knowing where the code came from, I know what bits to look for. In France, another real hotspot that they're seeing here is actually 6RD. When I showed that graph earlier that showed the traffic jump when they announced the Quad A for YouTube, right? A big chunk of that was in France, over 6RD. It's a tunneling technology that gets you across the last mile. It's managed service, and the way it's deployed is functionally no different than 6 to 4, except that the endpoint for the public side of the tunnel is managed by the service provider as opposed to being a public service that everybody goes to. Right? That's really the way it comes down. So, Google saw things this way. One of the partners at Cisco had done some work for one of the universities in Europe, and he got a slightly different take when he was looking at BitTorrent. Right? So BitTorrent is actually one of the apps, we were talking about apps a minute ago, and I said we'd come back to that, that has been out there a while that does v6. And in fact, there's a lot of XP machines that have v6 turned on. Why? You have to turn it on by hand. No, you don't. BitTorrent turns it on for you. And it actually works better, even if it's tunneling, than it does through v4. It's just there and it works. That's why they turned it on, right? But he gets a different characteristic. He sees a lot more out of China than he does Russia. Don't know why. That's just what he was seeing, right? These kinds of graphs will change over the next couple of years. As people are getting more natural native deployments, you'll get more shift in flows as to where things are coming from and going to. You'll also see a fairly broad shift in the available content. When I've gone and looked at BitTorrent, I've actually seen roughly a third what appear to be native, and I'm sure they're tunnel broker off of 6SS or HE, right? A third were 6 to 4, and the third were Teredo, right? And that was more than 2/3 of the peers that I could see. It's just, the stuff is there, and it's out there, and nobody even knows, right? They just installed the latest BitTorrent client. It turned it on. It started using it. You've probably got v6 running in your network today if you haven't intentionally made sure it's not there, right? The real issue is, at the end of the day, there is no one-size-fits-all network. I said this morning, right? So there can't be a one-size-fits-all answer for how we go about doing transition. Everybody wants the one simple answer. Yeah, that'd be nice, right? There's a lot of effort and constant churn in the IETF to come up with the standard way to do transition in the internet. And you just can't get there from here. What you can do is create a suite of tools that allow people to move what's locally business significant to them, right? The downside of that, you've got a lot of tools to sort through. You have to figure out what makes sense to you. And this is actually a good consulting business now, because if you know how all the tools work, you can go into each organization and help them figure out, okay, in your context, this is the best set of tools. Multiple approaches will exist for a long time. People won't like that. One of the things that has to happen is the service providers have to price IPv4 out of the core as quickly as possible. We were talking this morning during the panel about the market for v4 addresses. And the impact of that is you'll see lots and lots of addresses, smaller and smaller blocks. The routing table will go from 300,000 entries today in the default zone to 3 million as quick as they can run them through eBay. Yes, Aaron likes to believe that they will police this and it'll be needs-based. Markets tend to not pay attention to organizations that want to police them unless there's somebody that's enforcing. and there's not a good way to do that enforcement right now. All right? So we will see several million routing tables in the not too distant future. That means the big service providers that have default-free routes, and every enterprise that is multi-homed and taking default-free feed, every enterprise will have to upgrade their public-facing routers to the biggest routers made at an unconstrained rate. Right? Either that or you switch to default. Those are your choices. The only way you make that go away is to price v4 out of the core. I've talked to several service providers around the world who are saying, yeah, we're going to do this carrier-grade NAT thing, but it's not because we want to keep v4 running. We're going to break v4. This carrier-grade NAT is going to break v4. And if you want your working v4 back, you have to pay extra. We're going to price v4 out of the market. You keep jacking up the price on v4, and fewer people keep paying. Eventually it goes away, and you don't have to worry about it in the core. Now at the edge, yeah, you've got that 20-year-old printer, or the printer you just bought last week, right? That's v4 only. It's going to last for 20 years. Yeah, you're going to have to do translation at the edge for a very long time. But it doesn't have to be in the middle. So with that, I'll let Elaine pick up from here, and we'll move on. And I do have to apologize. I've got to catch a flight, so I'm out of here as soon as I'm done. So I hope you guys have a good day tomorrow. And